Our today's topic is Chapter 10, Section 1, Law of Sines. So we will start with a triangle. Doesn't matter whether it's isosceles or right angle triangle or equilateral triangle. So with an arbitrary general triangle, then the three vertex of this triangle, we're going to call them capital A, capital B, and capital C, where these letters also represent their corresponding angles based at the nearest vertex to the letter. So angle A is this one, angle B is this one, and angle C is this one. The opposite sides of each of the angles, we are going to introduce them by assigning the letter small a, which is opposite to the angle capital A, the side small b opposite to the angle capital B, and the side small c opposite to the angle capital C. With this setup, we are going to define certain rules about the triangles, measure of the angle, and the length of the sides of the triangle. And they are going to be called the law of sines and the law of cosines. First, we will talk about the ratio that comes from the symmetry, and that is called the law of sines. So we're going to say sine of A over A is equal to sine of B over B, and then sine of C over C, or if I call them alpha, beta, gamma, then sine of alpha over A is equal to sine of beta over B is equal to sine of gamma over C, or I can say A over sine of alpha equal to B over sine of beta equal to C over sine of gamma. So this is called the rule of sines, when the angle A can be denoted by the angular measure beta, the angle B can be denoted by the angular measure of beta, and the angle C can be denoted by the angular measure of gamma. Our idea is going to be solving triangles based on the sine rules, with the only exception of three different situations that we're going to tackle while working with the sine rule. And these situations are, what are those possibilities where there is no solution to the given information in terms of a real triangle? What are the situations when I can get two solutions for the given situation in terms of a real planar triangle? Or what are the situations when we can expect a unique solution to our planar triangles? The process of solving each of these problems is precisely the same. And let's start working on these problems, and we'll kind of get a little bit of better idea about this process. Use the law of sines to find the indicated side x. Assume c is equal to 27.7 units. Round your answer to one decimal place. Okay, so we want to know x. Remember what we have talked about already. So if you know two angles of this triangle, then you know the third angle of the triangle as well, because the sum of the three angles in the triangle is 180 degrees. So that is a major starting point for these problems. So let's write it down. Sum of the three angles in triangle. So I'm not writing it in a very perfect way of writing it. So the triangles that we are going to deal in our class are all planar triangles, and for them the sum of the three angles is always going to be 180 degrees, or if we are in the radian mode, then it should be pi. So we are going to start at that point. So as I said, we're going to say that the sum of the three angles in a triangle is either 180 degree or pi in the radian mode. So since two angles of this triangle are given to me, 52 degree and 70 degree, we're going to find the angle C. Then I can just say C for the angle C, or you can put this Langle notation to understand that this is an angle. So this is going to be 180 degree, the sum minus these two given angles, so 52 degree and 70 degree. So I get to say that this is 180 degree minus 112 degrees when I add these two quantities. In fact, I should have said 122 degrees. So then the subtraction will give me, let's see how much, 58 degrees. So that is this angle over here. And why this is important for us to know, because now we are in a position to use the sine rule. Remember, the side C is equal to 27.7. So what we have now? We have C over sine of C equal to, I want to know X, so if I say X, then I should say sine of the opposite angle, which is 52 degrees. So I'm going to use this much of the sine rule, and that's going to help us solve this problem. Let's see how. So first and foremost, you know the side small c is 27.7 over the angle of sine 58 degrees sine ratio, and that is equal to x over sine of 52 degrees. So if I'm trying to solve it for the value of x, I will multiply sine 52 degrees on both sides. So if I do so, I get 27.7 over sine of 58 degrees times sine of 52 degrees equal to x. And then the rest of the work is going to be done in the calculator. Remember, we're going to round it to 1 decimal places. So you will read your question instruction very carefully to understand how many decimal places you are rounding each answer. So times, I should be in the degree mode, and then I'm going to do 52, and I will take the sine value of that. So these two things are on the top, multiplied and divided by 58, and I still do the sine of that. So then I say that the value rounded to 1 decimal place is 25.7 units, and that is the answer to my first question. So it is pretty simple. Okay, let's carry on. The next question is, again, we are given with a triangle. Use the law of sines to find the indicated angle. Assume that the side C is 33 units. So see, this time you are given with two sides. You know, C is 33 units. You are given with only one angle. So I cannot use the sum of three angles 180 degree in order to find the angle theta. But what I can do, I can use the sine rule and say 33 over the sine ratio of the angle theta, that's the opposite angle to the side C, is equal to 45 is the length of the side over sine of 120 degrees. And remember, I'm trying to solve it for sine theta, so I can do what I call cross multiplication. So multiply these two and multiply these two. So you get 33 sine of 120 degrees equal to 45 sine of theta, and then you divide both sides by 45 because you want to isolate the sine theta. So that is pretty much it. So I'm going to say sine of theta is equal to 33 sine of 120 degrees over 45. So let's see how much we get for this answer. And as I said, this work is going to be done in the calculator. So first and foremost, we will find out how much is 120 degrees and take the sine ratio of that. And then multiply it by 33 and divide by 45. So that's what I'm getting. So I can say sine of theta is equal to this thing. So let's just write it down as whatever we're going to get for the value of theta. So instead of rounding in this step, since sine theta is this thing, I can go ahead and say that theta is equal to sine inverse or arc sine of this entire quantity, which is 33 sine of 120 degrees over 45. So remember, this number is already calculated for us. All I need to do at this point is take the arc sine. So I go arc sine for this one, and it tells me that the angle is going to be 39.4263, and I'm rounding to nearest degrees, so that should be the nearest whole number, so that should be 39 degrees. So I will go ahead and say that, well, this is approximately, the angle theta is approximately 39 degrees. Now there comes my first analysis of multiple solutions. What do I mean by that? So I have found one value for theta where it is 39 degrees. And remember what we did, we took the arc sine or sine inverse of the given value. So what do I mean by that? When we got this thing 33 times 120 and the sine value of that, and I divided by 45, this is the sine ratio value of an angle. Now remember, sine is positive in both first and second quadrants. So just because we had a positive value, nothing ensures that we are going to get the answer only in the first quadrant. Possibilities are that this answer could be in the second quadrant for my theta. So what are the possibilities for theta? One of them in the first quadrant clearly is 39 degree. The other possibility is going to be 180 degree minus 39 degrees. And remember, they are possibilities. So this situation, the second angle is going to be 10 minus 9 is 1, and then 17 minus 3 is 14, so 141 degrees. But if I were to follow the second option, then theta is 141 degree, and I already know that there is one other angle which is 120 degrees. So sum of two angles in this triangle at this point is going to be 120 degrees given, and I found the other one to be 141 degrees, which when added is 261 degrees, which is not possible because this is greater than the sum of all three angles. The sum of only two angles is greater than the sum of all three angles. So I say, well, that is not going to happen, not possible situation. So now I know this triangle has only one solution, and my theta value is only 39 degrees. I don't have to consider the theta in the second quadrant, which is not going to be necessarily the case in every single problem. You are going to always think about the value of theta being in the first quadrant or in the second quadrant, as in the triangle we always get the possibilities of a sine ratio being positive both in first and second quadrant. But essentially this problem, we have solved it. We wanted to know how much is theta, we have found it, and we are done. So we're going to carry on to our second problem. So choose the right triangle. Angle alpha is 50 degree, beta is 73 degree, and C is 270. So when I say choose the right triangle, I'm actually not asking you to do a right angle triangle. I'm talking about the find the right triangle. And we're going to find all these information and round this side lengths to the nearest integer. Okay, so let's start talking about this thing. So draw an arbitrary triangle, not in any particular shape. And then you call the angle ABC out. It doesn't matter which one is what, just level them and then talk about their measures given. So this is A, and that's 50 degree for me. This one is 73 degree. And I have been given with the length of the side C. Remember, the side C is the side opposite to the angle C, which is 270. So the first thing that we will work out is finding out the angle C. And that is easy because the angle C is going to be 180 degree minus 50 degree plus 73 degrees. So this is 180 degrees minus 123 degrees. And then when I do the calculation, I get 57 degrees. So that is your angle C. We have found one information already. So you can put that in. That's 57 degrees. Now remember, I'm going to find out two sides, and these sides are A, that is missing, and the side B. So how do I do it? Again, I'm going to employ the sine rule. Remember, A over sine of A, and the angle A is 50 degree for us, is equal to, the side you know is C, so I'm going to use 270 for that, and is sine over 57. And remember, this is the only side I'm going to be able to use because I do not know the other side B. So that's the equation that we're going to solve for the value of A. So multiply sine 50 degree to both sides, and you get A equal to 270 times sine of 50 degree over sine of 57 degree. Similarly, we can find the other ratio, the other triangle. So what I'm going to do now work out B over sine of the angle B, and that was 73 degrees, the angle B for us, is equal to, again, I know 270 the sine over sine of C is 57 degrees. So multiplying sine 73 degrees, I get B equal to 270 times sine of 73 degrees over sine of 57 degrees. And either of them, we're going to work it out in our calculator and round to the nearest integer. That's what the instructions say. So let's first do sine 50 degrees. And then you are going to multiply 270 with that and divide by 57 degrees and the sine ratio of that. Rounding to the nearest integer, we get 247. So A is 247, and we're going to find out the value for B. And again, remember what we are doing, simple calculation in the calculator. You're finding 73 degrees sine ratio, multiplying by 270 and dividing by 57's sine ratio. Rounding to the nearest whole number, it's going to be 308. So that kind of answers my question in this way. And we're going to put these two values in. So we'll say small a, the sine, is 247. Small b, the sine, is 308. For some reason I have put the degree notation there. It's the length of the side, there is no degree there. Alright, so we have answered this question now. And it is asking me to choose the right triangle out of these choices. So what we will do, we will look for the different sides we have found out, and we will talk about the angles, the measurement of the angles that we are aware of. So first and foremost, see, the angle C that we have found out is equal to 57 degrees. So this choice cannot be the right choice because it says angle C is 50 degrees. This cannot be the right choice. It's angle C equal to 50 degrees. So it's going to be either between A or B. Now remember, your angle A for this problem was 50 degrees. So that tells me that this one is not the right choice. Actually, both of them can be the right choice, isn't it? Yeah, because both of them are saying angle A is 50 degrees. This one is angle A here, so it's 50 degrees. So now I do what? I think about the length of the side. Remember, the side C is 270, but this is side A being 270, so that cannot be the right choice. So now I know that this is the right choice of the triangle. Okay, let's carry on to our next problem. Again, I have been given with a situation, and we're going to try to find out the number of solutions, 1, 2, or none. So use the law of sines to solve for all possible triangles that satisfy the given conditions. If an answer does not exist, enter D and E, round your answers to one decimal place, and below enter your answers so that B1 is smaller and B2 is the larger one. So as we talked about, draw the arbitrary triangle, name the angles A, B, and C, doesn't matter where. Angle A is given, and that is 38 degrees, and that's the only angle given to us. Side A is given, and that's 34. Side C is given, and that's 45. So that's how I'm going to level the triangle, and then start working on it. So what I can start by saying that let us name this side B, and this angle is your angle C, this angle is your angle B, and we're going to find this information. So because we are given with two sides, what we can do, we can say that 34, the side, over the angle 38, that's the opposite angle, the sine ratio, should be equal to 45 the side, and remember the angle opposite to it is C, and I do not know that, so I'm going to solve it for C first. Okay, let's start working on this. So again, if you remember, what we did is cross multiplication. So we get 34 sine of C equal to 45 sine of 38 degrees. So sine of C is 45 sine of 38 degrees over 34. So C, as you can recall, is the arc sine or the sine inverse of 45 sine of 38 degrees over 34. And remember what I told you, that should be your first choice for C. The second choice for C, first you find this angle and then subtract from that angle from 180 degrees to see the possible value in the second quadrant. And we're going to check which one of them are nice and which one of them is not nice. So let's work it out. I have 38 degrees. I take the sine ratio of that, and then I'm going to multiply that by 45 and divide that by 34. And then take the inverse sine of this thing. So this question was asking me to round your answers to 1 decimal place. So if I round this angle to 1 decimal place, I get 54.6 degrees. Okay, so I said that C1 is 54.6 degrees. What is C2? Well, C2 is 180 degree minus 54.6 degrees. So that quantity is going to be 0.45, and then you have 17 minus 5, so 1, 2, so 125.4 degrees. So far we have two angles found out. We have the angle A given to us, we found angle C. So in either situation, let's find the angle B. So because I'm finding it for C1, I'm calling it B1. And this is now simple because you're doing 180 degree minus 38 degree was the given angle, and you found 54.6 degrees. So I get 180 degrees minus 8 plus 4 is 12. 3 plus 1 is 4 plus 5 is 9.6 degrees. So that's going to be 0.4. 9 minus 2 is 7. 17 minus 9 is 8. So 87.4 degrees. And so this is a pretty nice set of solution. Your angles are 87.4 degrees. And you have 38 degrees as your other angle. And you have 54.6 degrees. So that seems like a very nice solution. How about the other situation? So I do the same thing. I find B2 in this situation, and in order to do so, I will do 180 degree minus 125.4 is the one I found. 38 is the other one given to us. So I get 180 degree minus 5 plus 8 is 13. 2 plus 1 is 3 plus 3 is 6. So 163.4 degrees, which is 9 minus 3 is 6, 17 minus 16 is 1, so 16.6 degrees. And what we have found out, this is also pretty nice. I have good angles, 16.6 degree, 120.5 degrees, and the other angle is 30 degree in either situation. So this is a pretty nice situation. We are getting two sets of solution. What does that also mean? Remember, we found all three angles and we have information about two sides. We did not find the side B yet. So that's what you're going to do now. And I will have two different solutions for side B, or not. Let's see. So side B over sine of B is equal to A over sine of A. That is the formula. I know all of these angles. And remember, sine B is going to have two different solutions. So sine B over, this time I'm using sine B1. And we just found B1 is 87.4 degrees. So that's 87.4 degrees here. Is equal to A over sine A. You know the side A is given to us. If I go back to the triangle, we'll find out that the side A is 34 and the angle A is 38 degrees. So that's pretty simple. 34 over sine of 38 degrees. And then as we are solving it for the side B, I'm going to multiply sine 87.4 degrees on both sides. So I get 34 times sine 87.4 degrees over sine of 38 degrees. The rest is calculation. So let's see how much we get. And we're going to round to 1 decimal place, that we should not forget. 87.4 is the sine ratio. And then we're going to multiply 34 with it. And finally, we're going to divide by 38's sine ratio. Rounded to 1 decimal place, it's 55.2. So that's your first observation for the side B. And as usual, we're going to do the similar work one more time. This time, I will say B over sine of, remember it is 16.6 degrees. This is the second B value that we have obtained. And that is going to be, the right hand side doesn't change. It is still 34 over sine of 38 degrees. So small b, the side length, is 34 times sine of 16.6 degrees over sine of 38 degrees. And again, we calculate and round to 1 decimal place. So as we see, we first do 16.6 as the angle, take the sine ratio, multiply by 34, divide by 38's sine ratio, and round to 1 decimal place. So that's 15.8 rounded to 1 decimal place. And that has answered all the question for me. So when we are filling in information, we have two sets of value for B1, as you can recall. So remember, what are the values for B1? We got 87.4 degrees. And we also get 16.6 degrees as the other set of value for the angle B1, the angle B, and we're calling it B1, B2. So again, I think it's B1 is the smaller one, so I have to swap those answers because B1 is the smaller one. So this one is the 16.6 degrees, and B2 is the larger one, which is 87.4 degrees. So let's do the C1, C2 accordingly. So the C1 is the angle C for 16.6 degrees when that is the angle B. So it is 125.4 degrees. C2 is the angle for B being 87.4 degrees. So that's 54.6 degrees. Small b1 is the length B when angle B is 16.6 degrees, and that's 15.8. Small b2 is the length of the side B when angle B is 87.4 degrees, and that is 55.2. And that has completely answered this question for us. So this is the general strategy for every problem that we would like to solve in this set. So we are seeing some word problem, and this one is to find the distance across a river. A surveyor chooses points A and B as shown in the picture, where the points are 250 feet apart on one side of the river. So now I know that X is 250 feet. C then chooses a reference point C on the opposite side of the river and finds that angle BAC is 82 degrees and angle ABC is 52 degrees. Approximate the distance from A to C and round your answer to the nearest foot. So that means we're going to round to the nearest integer value. So we are going to find the side AC, and this side is opposite to the angle B, so I can call it small b. That will help us notation wise. Remember, the easiest angle to find out is this one, angle C, and that is 180 degrees minus 82 degrees plus 52 degrees. These are the known angles. So 180 degrees minus 134 degrees, which is going to be 46 degrees. Then use the sine rule. You want to know how much is the side B. So B over sine of B, which is 52 degrees, is equal to, the only side I know is side C, which is 250 feet. over sine of the opposite angle, and which I just found as 46 degrees. Multiply sine 52 degrees on both sides, so B is 250 times sine of 52 degrees over sine of 46 degrees. And then use calculator, round your answer to the nearest integer. So 52 sine, and I multiply 250 with it and divide by the sine of 46, which is 273, and rounded to nearest integer, I can call it 274. Unit is in feet, so that is the distance between the point A to C. Answers my question, pretty simple. Similar question, to find the distance AB across a river, a distance BC, 200 is laid off on one side of the river. So BC is clearly here, and that is 200 units. It is found that the angle B is 97 degrees. So this one is 97 degrees. Angle C is 27 degrees. Find the side AB. So I want to know this side. Remember, this is the opposite side to the angle C. So you can also call it C here. So this seems like a problem that we have already done in the last one. And then we are going to answer the question, and let's just, because no information is given here, we're going to round to the nearest 4 decimal places. So two angles are given, so it will be easier to find the angle A here. And that is 180 degree minus 97 degrees plus 27 degrees. So 7 plus 7 is 14, and then 10 plus 2 is 12. So I get 56 degrees. And then sine rule. So I want to know the side C, so I will say side C over sine of C, which is 27 degrees, equal to, the only side you know is the side A, so that's 200 over sine of A, and we found sine of A to be 56 degrees. Multiply sine 27 on both sides, so C is equal to 200 times sine of 27 degrees over sine of 56 degrees. Okay. So calculator, and we said we will round to nearest 4 decimal places. 27, take the sine of that, multiply by 200, and then divide by 56 and the sine of that. So it's 109.5223 units. That is the distance between the points A and the points B, which we wanted to know. Answers our question. Let's see what else we have. Okay, so we're going to find the answer to the question where it is talking about a communication tower, the side CB, which is located at the top, the point C, of a steep hill. So what we are dealing with here is a problem without the picture. So first thing, we're going to kind of try to draw the situation. This is the steep hill, and the top of the hill is the point C, and there is this communication tower, which is called CB. A guy wire is to be attached to the top, the point B, of the tower, to the ground, the point A. So something along this line. This is the guy wire, and the point A is on the ground. It is also known that the point A is 95 miles downhill from the base of the tower, the side AC. So basically, base of the tower is C, and from that, downhill distance to the point A is 95 miles. So this is 95 miles. Very good. The angle BAC is 12 degrees. So this angle over here is 12 degrees. Find the length of the cable, the side AB, required for the guide wire. Now remember, there is one other information. The angle of inclination of the hill is 58 degrees. So angle of inclination of the hill. So this is the top of the hill, and what we know that this angle of inclination from the ground to the top of the hill is this one over here is given as 58 degrees. So this is the setup for the problem, and we're going to use this setup in order to understand the rest of the missing information in the problem. So of course, one thing I can think of is that we are trying to answer this question in terms of the sine. So the first thing I want you to understand, if I extend this side, then along with this side, the base on the ground and the guide wire from the ground to the top of the tower is going to form a right angle triangle. That's my first observation. Now think about the base angle of the right angle triangle. It is the sum of the angle 58 degree and 12 degree. So if you add them, you get 70 degrees. Well, you already know this angle is 90 degrees. So what I am telling you now, you have a right angle triangle where you know two of the angles. So it is your work now to find out the third angle B. Well, what is B? B is 180 degree minus 90 degree plus 70 degrees. So it is 180 degree minus 160 degrees, and that's 20 degrees. So now I know this angle is 20 degree over here. Then forget about the right angle triangle, because in our problem we are going to look at the triangle that I am assigning the color green now. So what we know this angle is 12 degrees. We know this angle is 20 degrees. We know this side is 95 miles. And we wanted to find out this side. So since I know two of these angles, I know the angle C as well. So the angle C in our triangle is 180 degrees minus 12 degrees plus 20 degrees, which is 180 degree minus 32 degrees. And when I do the subtraction, I get 148 degrees. So this angle over here is 148 degrees. Let's see whether we can use the sine rule of sine now. Well, what I need to do, think about what I need to find out, the side AB, the length of the guide wire, over the sine of the opposite angle, which is 148 degrees. What you do know is the side 95 miles over the sine of the opposite angle, and I do know that angle too, that sine of 20 degrees. So it is easy for me to solve for the side AB now. So side AB is 95 times sine of 148 degrees over sine of 20 degrees. And we're going to use our calculator. We wanted the approximate length of the cable. Because no information is given for rounding, we're going to round to the nearest 4 decimal places. So let's see, we're going to find 148 degrees and the sine of that, and then we're going to multiply the length 95 with it. And finally, we're going to divide that quantity by the sine of 20. So that's 147.1911. Is, and the unit is in miles, so we'll say that is my answer to the question. So the length of the guide wire that we wanted to find out is 147.1911 miles. That answers this question, and this also answers all the questions that we have in our lecture note for the rule of sines. You keep working on your homework problems. If you have questions, send me an email or come to class, we will talk about it. Next time, you will see the video for the rules of cosines.